mineral insulated copper clad cable, sometimes known as pyro. We're going to look at how we strip it, gland it and make it ready for termination. So the tools we're going to need, there are 3 different tools we can use to strip it. We can use a joy stripper, which can be set to the size of the cable. On the outer marker, the outer body of the tool, we can set the size of the cable. So this one is set to 2L1.5, so that's 2 core lightweight 1.5mm conductors. We're going to need the alternative. The next alternative is a rotary stripper, or we can use effectively a key like you would use on a sardine tin or a corned beef tin, and for that we will probably also need something to actually ring off the cable, the copper sheathing, at the point we want to end stripping it back. So, as with stripping and glanding SWA or armoured cables, we would fit the shroud first and then decide where we need to strip back to, bearing in mind the length of the conductors needed and enough external exposed to fit the gland body and the pot at the end. So if we were to mark off, ring the cable, strip off the outer sheathing, the outer protection, and exposing our solid metal copper cladding, straighten it out as best we can. So we're now ready to strip it back. So we'll look at the 3 different ways of stripping it. First off, we'll use the joy stripper. So to make our life a little bit easier, we're going to apply a little bit of lubrication to the outside and then put the joy stripper on to the mineral cable and just make sure that it starts to bite in, and as it's going we can see that it's removing the outer casing and releasing the magnesium oxide from inside. So we're going to keep stripping this back. And then when we get to about where we want to strip to, we can use a pair of pliers just to stop that stripping anymore. We can remove the joy stripper, and now we've got our 2 conductors exposed with a nice clean end that we can start to think about attaching the gland body and the pot. So the 2 other methods, looking at the rotary stripping tool, this one can be adjusted to fit the size cable, and then the cutting disc will sit just over the top of it and will cut in as we start to turn it. So we need to, again, before we start anything, a little bit of lubrication to make sure it runs smoothly. And we're going to want to have this so that as the cable goes in, it sits up against the wheel but not protruding beside it or alongside it. We're going to tighten that up and then start to rotate the stripper. We might need to hold that with some pliers or in a vise so we can start to turn that, and as we start to turn it, the wheel starts to cut through the outer insulation. Again, we can carry on stripping that outer cable and outer insulation off, allowing the magnesium oxide to come out. When we've reached the point we've stripped enough of the outer off, we can again hold it with the pliers and rotate it, and that will remove the outer covering and expose our internal conductors. Again, all the magnesium oxide is out, and then we just pop that up in exactly the same way. So that's using a rotary stripper. And then the last way we need to look at is the key that is reminiscent of a tin of corned beef. So we're going to slide the gland body on, and normally there would be an olive between these, and it's similar to a plumbing olive, but we're not going to use them, we're not going to waste them. And we're going to make sure our conductors are out straight, as clean as they can be, and we need to now look at the pot themselves. So there's two kinds. You can have a straight pot where that will thread onto the copper casing of the pyro, the MCC. You can have a standard pot where that will thread onto the outer body of the MICC cable, and then that will use the outer copper as the CPC, or we can use a threaded pot where that's clearly got an additional conductor in it which will thread onto the outer sheathing, and then this will act as a CPC. So either way, it's the external material of the MICC acts as a protective conductor. So we're going to take our pot, thread the two conductors through. I'm going to take our pot, slide it on, watching we don't damage the two conductors that are there, and we're going to try and get this to thread on, and that starts to cut its thread into the external material of the copper outer. And now I can use either a potting tool, a potting spanner. So we can use a potting spanner where we can attach this to the pot itself, do that up, and then that will allow us to twist the body of the pot, and that self taps onto the outer insulation of the MICC, and we want that just to come into the pot but not protrude too far, and then that will fit it. Or you can put the pots on with a pair of combination pliers. The important bit now is that's threaded on with a self-tapping thread. We need to make sure that doesn't go to loosen. If that loosens, then we're going to lose the connection between the pot and this, effectively the outer CPC. What we now need to be careful of is making sure that the three conductors now don't touch each other. So the only thing we've got stopping any shorting is essentially at the moment the air gap between the two conductors and the CPC. We need to get rid of any of the magnesium oxide inside, and we do that by tapping the pot to get rid of any excess. Bear in mind, magnesium oxide is hygroscopic, so if we blow into this pot to try and blow the dust out, there's a chance that the moisture in your breath will get sucked into that magnesium oxide and possibly lead to a short between the conductors. To try and maintain this gap between all three conductors, we're going to fit a cap which takes all three conductors, trying to keep them in a position where they're not going to twist or bend. I'm going to slide this cap down until it's almost ready to fit, and then now we're going to take some potting compound and we're going to feed this in from the back of the pot in a pressing motion, forcing all of the air out and putting the potting compound in between all of the conductors until it's filled the pot. We can then push the cap into place, clearing off some of the excess potting compound, which is now ready to go in the bin. Make sure we're keeping the remainder of the potting compound clean. And we now need a crimping tool to press the pot cap into place. So these are available for different sizes of pots and caps, depending on the MICC we're using. and it's going to push down, and the prongs on the plate are going to leave divots in the cap, and as we go down we can see it's going to squeeze out any excess compound until that's tight, and we can then back that off remove the tool and clean off any excessive compound. So we should now have our 3 conductors potted with the compound. That's going to keep them all separate. Clean the compound out, and then that's now ready to fit into whatever we're going to fit it to, whether it's going into a galvanised box as part of a conduit system, or into a patras, a metal surface box, a metal clad box with a lock nut, whatever it is that's going to fit it into that system. So it's important then, when the ends are made off, when they're terminated, that we need to check that the MICC is not shorted out. So we need to first off check that the CPC is intact, and again we can check that the pot CPC is as it should be. So we're checking on an insulation resistance setting, and now we'll go from essentially the CPC to the 2 conductors, and we'll see that we've got no connection and no connection, but we can now go across the 2 conductors to identify which conductor is which would allow us to then sleeve it to identify those conductors. So as we've identified that conductor, we can sleeve it for identification purposes. We've checked that there's no continuity between that and the outer casing, so there's no shorting across the CPC. Having identified the conductors one at a time, we can sleeve them for identification purposes. You can check there's no short between the conductors. And that's one length of MICC cable made off with using the joy stripper to remove the outer insulation.